Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 28, 2025, which was just 4 days ago. The standout idea is that large video datasets provide common-sense priors, so the model learns multi-view spatial consistency and richer semantics for far better 3D generation, despite scarce native 3D data. The paper is titled, Droplet3D, Common-Sense Priors from Videos Facilitate 3D Generation. And as we will see later, the implications for model training are quite significant. In short, the team releases Droplet3D-4M and a video-driven generator that together produce spatially consistent, text-faithful multi-view outputs and open-source the full stack. Also, the authors shared their GitHub repo. You will find a runnable inference demo, setup instructions, and requirements, plus scripts like inference, pipeline, transformer, VAE, and utils. The README explains checkpoints on Hugging Face, command line arguments, and view alignment via LoRa. There is also a Chinese README and assets for examples. On Hugging Face, Droplet3D5B offers downloadable 5 billion parameter weights with T5 text encoder, plus examples for running inference via Python script using prompts, reference images, and view alignment. Figure 1 conveys the core message. Videos inject common-sense priors that make 3D generation both spatially consistent and semantically faithful. The left panels illustrate two priors, where multi-view clips enforce the same object across angles, and everyday objects teach names and functions. The right panels show the system taking an input image with long text and producing coherent front, back, and side views, which demonstrates controllable edits, like adding a control panel or a QR code. Alright, Figure 2 shows what one dataset entry actually contains, which matters because it proves the supervision is both spatial and semantic. The left panel presents an 85-frame orbital rendering that circles a character, so the views stay consistent across angles. The right panel provides dense, multi-view text, where color-coded sentences track what changes as the camera rotates. Together, these paired views and words teach the generator which details appear when perspective shifts. So, Table 1 makes the scale and annotation depth concrete, showing that Droplet3D-4M pairs 4 million objects with 85 synchronized views and long, multi-view text. Multi-view means the same object is rendered from many angles, which teaches spatial consistency by design. The bottom row highlights 900 million images and about 260 words per item, which far exceeds prior sets. This combination signals stronger supervision for both geometry and semantics. Alright, Figure 8 outlines the full pipeline, which turns a single image plus dense text into multi-view images and then production-ready 3D assets. The left blocks show alignment, meaning the system rewrites the text and maps the input view to a canonical view so conditioning stays consistent. The center stack encodes and decodes video latents with a 3D causal VAE and a modality-expert transformer. The right blocks convert the surround views into textured meshes or Gaussian splats. Wrapping up, two takeaways stand out. Leveraging videos injects common-sense priors that unlock multi-view consistency and stronger text faithfulness, and scaling with Droplet3D-4M plus a video backbone delivers practical 3D assets from a single image and dense text. The broader implication is scene-level 3D becomes attainable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.